And last but not least, this is the final problem of the chapter. This is number 144, and let's see what we have covered. So far in this series, we've gone from height from pressure, pressure in a system at a point, force in a chamber, fluids acting on object, buoyancy, fluid in motion, and now we have height with the centripetal or centrifugal, whatever, force. And the only equation we need to know for that one is that equation right there. So for this problem, let's see what we have written now. So we've got almost like a little beaker looking thing with a fluid, and we know that this is height h and that there's going to be h prime, and we know that it is getting spun, and we know the overall is 0.2 meters. This can be h plus h prime equals 0.2 meters then. Okay. No. I'm mistaken. Sorry. 1.5 meters. This is just telling us the height of the glass. H prime is below the height of the glass. So it's going to be below this. So now what we're asked to find is, first, see what we're given. H equals 0.1 meters, and that velocity, weird looking W, is equal to 15 rad per second. Okay, that's what we're given. We're asked to find what h prime is. Now remember our equation from earlier? Only one that we need to remember right here. We know that h prime is equal to gamma squared 2g r squared. So h prime is equal to our 15 rad per second over 2 times 9.81 meters per second squared times our 15 over 2 meters going from diameter to radius squared. So plugging all of this in, we've got 15 over 2 times 9.81 times 15 over 2 squared is 43. Is that right? 43? I don't think it should be squared. Oh, I forgot to square the W. Never mind, this should be squared. That should also be squared. There we go. Sweet. And I forgot to set this is 0.15, not 15. There we are. So this is 0.0645 meters. So now for our h prime, what we need to do is we need to say that h prime will rise 0.1 meter plus our 0.0645 meter. Divided by 2. So our final height is going to equal 0.132 meters, or 132 millimeter. Okay, and quickly, why is this divided by 2? I had to think about this for a second. So remember in the truck problem how the fluid started static and it did this when it was accelerated, where we had some h here and then some h here, and this whole thing was a delta h. Well, with the centrifuge force, we have a resting fluid here, and as it's spun, it's going to do the same thing. Some of it is going to go below, and some of it is going to go above. And this is our delta H, which is this. So we want to know what is this part right here. So this is going to be 1/2 delta H plus our initial, which is 0.1. So same thing with the truck problem happened here. And there's your final answer. Sorry for explaining it after and not before. I had to think about it for a second. So, all right. Thanks for watching.